Hi everyone, let's get started. Thanks for joining. I hope you're having a good time this second day of DevOps. I'm super excited to be here in London this year. Today I'm going to talk about Spring Cloud Gateway, resilience, security, and observability. That's a lot of words out there, so let's see what's that all about. First, something about me. I'm Thomas. I work at Systematic, a Danish software company, where I work on healthcare software products. I'm a software architect there. I'm really passionate about anything cloud native, about Java and Spring. I'm even writing a book about it. It's called Cloud Native Spring in Action with Spring Boot and Kubernetes. Also, I'm a big supporter of open source technologies and being part of the community. So every time I can, I contribute to open source projects. For example, I like contributing to Spring Security and Spring Cloud. Before diving into technology, let's talk about why even talking about the gateways. So why am I here today? So what problems are we trying to solve? What's the API gateway pattern, and when it makes sense to use it? We have different scenarios where we can adopt this pattern and get benefits out of it. The first scenario is when we have different clients with different APIs. So from the client side, we don't want to have coupling between the clients and whatever happens in the backend. We want to be able to be free to change the APIs inside our system without affecting the client, so ensuring compatibility and making sure that we don't break any existing functionality. So in that case, a gateway could be a good point for a good place to do this, to shield the clients from any change that we might want to do in the backend and keep a consistent API for clients. Another scenario is, for example, if we have a monolith and we want to start extracting some functionality as microservices. For example, we identify a piece of functionality that we want to scale independently, that we want to deal with separately from the monolith, but at the same time, we don't want to disrupt the business we have today. So the monolith is there, it's producing value, so we don't want to add risks to our system. So what we can do is using a gateway. So once again, we keep consistent the API towards the clients, and then in the backend, we can extract this piece of functionality out of a monolith, create a microservice, but the client will never know that that is happening. Then we can create a unified interface for microservices. Once we switch to these distributed systems, we have the problem that clients then would have to keep track of all the services that we have in the backend, and we don't want that. We want one entry point, one single access point to our system in the backend. And for that, we can use a gateway. Finally, since we have now identified the gateway as the entry point to our system, we can also start implementing there and handling some cross-cutting concerns like security, like resilience, and observability. And today we'll try to address some of these scenarios using Spring Cloud Gateway. We're gonna deal with a system like this. This is just an example. We have a system for a public library. The users are members of the libraries. The entry point will be what we call an edge service. It's a service at the edge of the system. And in there, we can implement not only an API gateway, but also handle all those cross-cutting concerns that I just mentioned. And then in the backend, we can have whatever we want, how many services we want, and using whatever technology we want. So the fact that we're going to use Spring Cloud Gateway to implement the edge service doesn't mean that we have to use Spring for all the other microservices. So we can use different technologies and languages. It doesn't matter. They are all independent from that point of view. We're going to focus on one of the backend services down there, book service, but the same is true for other microservices that you might want to have in the backend. Before moving to Spring Cloud Gateway, we have to solve a problem. So we are talking about introducing a new system, a new service inside our architecture. So we are adding, first of all, something new that we have to maintain. That's extra cost. So nothing comes for free. It's something new that is sitting between the clients and the backend services. That means that we don't want to make it a single point of failure, both from an error point of view, but also we should consider latency. We are adding an extra hop, and we should consider the capacity, so how many requests we can handle concurrently, because we have high chances of turning this gateway into a bottleneck, and we don't want to do that. So Spring Cloud Gateway adopts a reactive programming paradigm in order to overcome some limitations of the thread per request model, which is what we would usually use in a servlet-based applications, where for each request we allocate a thread, and that thread blocks waiting for some I/O operations. Of course, these problems here will be mitigated by Loom, but in this specific case, we really want to be decoupled from the thread pool. Because with this model, if, for example, Tomcat has a default thread pool of 200 threads, that means that at the same time you can handle 200 requests, not more. If you want to handle more requests at the same time, you have to increase the thread pool. So that becomes dangerous, because we would end up having a gateway which is very expensive, which is very hard to maintain, and not very much fault tolerant. So we switched to an event loop model. And that's what Reactive Spring is based on with Project Reactor. So we don't have the one-to-one mapping between a request and a thread, but we have an event loop, and threads will just pick up new work as it arrives, and they don't keep hanging waiting for a response to be received from a database or from another service in the backend. In this way, we can ensure better scalability, better cost optimization, and also better resilience. So this is the foundation of Spring Cloud Gateway, and it's based on the reactive stack of Spring. So we're going to have, for example, all projects have a reactive counterpart. We're going to see some security concerns today, and we're going to use Spring Security in a reactive stack. The first function for a gateway is routing. It's very basic. So let's start with some example right away. So I'm going to go to start.spring.io. I can create a new Gradle project, and the only dependency I need to bootstrap this edge service, this gateway, is the Spring Cloud Gateway dependency. That's all I need. Then I have already created a book service. It's a very simple service with one HTTP endpoint returning books. So let's give it a try, just to confirm that it works. Yes. So it's running on port 9001/books, and we get the books back. So what we want to achieve now is not calling book service directly. We want to go through the edge service. So the result will be the same, but we're going to call the edge service directly in a moment. I have already opened the edge service project. I have initialized from start.spring.io. And this is empty, so don't mind the red imports. IntelliJ decided that this morning didn't want to find the dependencies, but it works. Yeah, what can you do? And if I go then to the property file, I can start defining routing rules. Now, you have two options when it comes to configuring Spring Cloud Gateway. You can use configuration properties, or you can use the Java DSL. Now, live coding with Java would be much easier for me, because the IDE should help me. But I decided to live code in YAML. So please, yes, happy thoughts for me that it's going to work. But I'm doing that because in a production scenario, I want to have the flexibility to change the routing rules and, in general, the configuration of the gateway without having to rebuild the application. So I'm not going to use the DSL, because most of the times in production, I'm not going to use the Java DSL. So I want to show you something that is really relevant for a production scenario, even if it's a bit harder to demonstrate live like this. So we have, I think it's big enough there. We have the Spring Cloud property here for the gateway. Now it's not even helping me. Oh, that's perfect. Yes, this is going to be interesting. So we'll define a route. A route is identified by an ID, for example, book route. Then I have to define where to send the request when it comes to book. Yes. So on my local environment, I can redirect the request to localhost 9001 when my book service is running. But in order to make this configurable, for example, if I run it in Docker or Kubernetes, I'll introduce an environment variable here. I'll call it book service URI. And the syntax means that if this environment variable is defined, then I use the value from the environment variable. Otherwise, it falls back to localhost. That's the default value. Then I have to define a predicate. A predicate is what the gateway will check in order to figure out if this route is the relevant route for a certain request. And in particular, I want to make sure that every time the path starts with /books, then the book route is activated and the request is directed to book service. And so far is well, not that much interesting. So we are creating a simple proxy. So let's try to make it slightly more interesting to begin with, because I can start introducing some filters. So before sending the request downstream, I can manipulate the request in some way. For example, I can add a request header. And I can even manipulate the response when it comes back. So we can say, for example, a tenant. Like, let's say we have a multi-tenant application. This is a good place to handle that. And the tenant will be Acme. And then we have a response header. So we are dealing with books. So we can have genre, fantasy. They're all fantasy books. So now when I send the request with /books, then the request is sent down to book service, and the filters are applied. Let's give it a try. I'll move to the branch in here. Perfect. There it is. We have our book route. So I'll start edge service now. And it was already running. Let's see. Thank you, IntelliJ. Yes. So let's figure out what's going on. So we have the gateway dependency. Yeah.
There's another one down there. Can you scroll down?
Oh, thank you. That was interesting. Cool. Okay, let's run the application. Now, before I call directly 9001, now I call 9000. That's the edge service. And I get the request, the response, the same response as before, but you can see that the response has a new header there, xgenre fantasy. So at this point, we are starting introducing this new component. We have a distributed system, and things start becoming difficult when it comes to debugging, but even when working locally, in order to keep track of how the requests are flowing through our system. So I want to start right away to talk about observability. I really believe in pushing observability left. It's not only useful in production, but it's really useful also when building these systems, so the development phase. And what we can do, I have deployed all this system on a Kubernetes cluster, so we can send some requests there. we have the edge service URL. So I can send the same request now with /books. We get the same response body here with the extra response header. And if I move to Grafana now, we can inspect a few things. So for example, I could check the logs from the application. Let's give it a second to run. We can check from Tempo. This is a distributed tracing backend system that I hooked up in Grafana. We can check the traces, and we can check the Prometheus metrics. New app. Let's see which one we are using. That's 02. Yeah. Well, moving on for logs, I want to show a few things. So logs, we have by default all the log messages printed out to standard out in Spring Boot. That's perfect. That's what we want in a cloud-native system. What I have added on top of that, two things. First of all, I added a Spring Boot Actuator. Spring Boot Actuator is a great library because it provides a lot of management and monitoring endpoints out of the box. For example, it exposes the health of the system with liveness and readiness probes, which are really useful in Kubernetes. It exposes metrics. You can choose the format. It has support for a lot of different systems, thanks to the micrometer facade. In particular, I'm using Prometheus now. And then a bunch of other endpoints that are really useful in specific situations. For example, if you're using Flyway to handle schema migrations, then it will have a Flyway endpoint where you can monitor all the migrations that have been run. You can take a thread dump and a heap dump. You can check the configuration. There's really a lot of different cool information that are really useful and precious when putting the system in production. And then for the tracing part, we can use Spring Cloud Sleuth right now with Spring Boot 2 and Spring Framework 5, but from the next major version of Spring, that has been moved to the micrometer tracing project. So we're going to have a very similar and consistent way of dealing with metrics and with traces in the same way. So we're going to have the micrometer metrics library and micrometer tracing. And that has support, so it provides a facade like micrometer, but you can decide on the implementation. For metrics, we're using Prometheus. For tracing, we can use OpenTelemetry, for example. And what I'm using right now is a stack based on Grafana. It's all open source. As I mentioned, I'm using Prometheus for the metrics. I'm using Loki for logs, Tempo for traces, and Grafana to have this single access point to all possible signals and telemetry from my system. I find it really useful to have this in place also when I'm developing new solutions, not only in production. And that's because distributed systems are complex. And when we have the gateway and we have to deal with the flow of requests, I find it really, really useful. So the routing part is there. But again, it's pretty basic. We have talked about observability, but we can do more. So what's so special about this? Let's go back here. We have this basic architecture where a request is handled via some predicates, a route is identified, we can apply some filters, and what we have done so far, manipulating headers, is cool, but we're not quite there. I want to have something more resilient, something more secure, and the key the secret to all these cross-cutting concerns, how to make the system better, is the filter mechanism. Because via filters, I can implement some resilience patterns and I can implement security. And we're going to start by looking into resilience. Resilience means that we want our system to be fault tolerant. It should be up and running. It should be available for our users when they need to use our system. Worst case scenario, we should have some graceful degradation of the functionality, but we shouldn't have a system down. So this is really important, especially in a distributed system when so many things can go wrong. Just think about the fallacies of distributed programming. So the first pattern that we're going to see is retry. So let's say I send the GET request to the gateway, and book service, for some reason, doesn't reply, or the request doesn't arrive to destination, or the response gets lost. Or maybe even I have a timeout that expires and I don't get any response. What can I do? I can perhaps retry a request. But that's a dangerous pattern, because we should really carefully think about what we are retrying. In the example, we have a GET request. A GET request is idempotent. I can call the same request many times. The result is always the same. But if I retry a POST request, then suddenly I can have several issues. So I should consider if a request is idempotent, then a retry pattern can be used. Otherwise, we shouldn't retry, because the risk is that the system will enter in an inconsistent state. A retry works like this. We have our edge service. With the book route, we send the first request to book service, but then we receive back a 503 error. It means the service is momentarily unavailable for whatever reason. Maybe it's so overloaded that cannot handle any more requests. So what we do is that we wait a bit of time, and then we try again the request. Once again, 503. So now we are not trying and trying again one attempt after the other. We are waiting longer delays between each retry. That's important, because we don't want to overload even more book service. So we want to give it time to recover. So we wait a bit longer, we send a new request, and finally the response is successful, and that's fine. If all the retry attempts that we configured are end in a failure, then we should think about what to do. Maybe we can send a friendly message to the user, please try again later, or maybe we have cached the response from a previous request, and we can return the cached data. That's up to us. Retries are a filter in Spring Cloud Gateway. There are several built-in filters that are all documented in the Spring Cloud Gateway documentation. And to address this filter, so for the headers, we used a very compact syntax, but for retries, we want to have more information in order to define these delays between each retry attempt and how many attempts I want to have. So now we have added a new filter in here. You can see the name is retry. This is provided by Spring Cloud Gateway out of the box. I want to have 3 retries, and this is an important part. I only want to retry GET request. Now this is up to me. I might have a POST request, for example, to update my profile picture. I can retry that request, because even if I send it twice, the result is always the same, even if it's a POST request. But in that case, it really depends on the specific context. But in general, I would assume that all GET requests follow the HTTP standards and are idempotent without side effects in the backend system. And then we have a backoff strategy. That means that we want to wait more and more after each retry attempt. So we start with a backoff of 50 milliseconds. And then there's a formula that is used to compute these increasing delays. And at most, we want to wait 500 milliseconds. If we don't get any response, a successful response, then we just give up. This is a very simple one, but powerful for GET request. And we are handling what can go wrong between edge service and book service. But we also have now the problem of what happens here. So at the entry point of our system. So edge service, we don't want to make it a single point of failure. We want to make it very resilient and robust. And one thing we can do in order to protect it, for example, from DOS attacks, is using a request rate limiter. So we know that we can support a certain amount of request, or that we want to support a certain amount of request. So what we can do is implement a rate limiter. So that's not only for resilience, but it's also from a business perspective. Let's say you have a subscription model in your product. So perhaps there's a basic user that is allowed to send a certain amount of requests per hour. But then if you get an upgrade and you become a premium user, then you can call your API more within the hour. So you can use it for resilience, but also to implement certain business requirements at the edge of the system. The request rate limiter that is provided out of the box in Spring Cloud Gateway is based on a model from Stripe that it's implemented and described by Stripe. At that link, you can find more information. It's called a token bucket algorithm. What happens is that for each user, we assign a bucket of tokens. They have a certain amount of tokens. Every time they send a request, they have to pay 1 token. When the bucket is empty, it means that they're not allowed to send any more requests until the bucket is filled with more tokens. And we can decide the time, for example, every second, every minute, every hour, whatever we want to achieve. Unlike the retry pattern is quite, you can say, stateless. So we don't need to maintain state. But for the rate limiter, suddenly we have a problem with state, because of course we're not going to have one single instance of the gateway running. We're going to have multiple ones because we want to achieve high availability. So what we need to do is storing the state. It's a distributed system. We want to keep the application stateless. So we need to use an external data store. And in this case, we're going to use Redis, which is one of the implementations provided also in Spring Cloud Gateway. So what I need to do in order to achieve that, so the rate limiter once again will be a filter, but I need to add now a dependency to integrate with Redis. So I'll switch branch. And in my build Gradle file, I have now a new dependency on Spring Data Redis Reactive, because we're working with the reactive application. And now I have access via Spring Cloud Gateway to this request rate limiter implementation. And since it should be applied no matter the route, it should be applied at the entry point of the system, I can use a default filter mechanism so that it's applied no matter the route. So I have 3 arguments there. The replenish rate 10 means that every second I put 10 tokens into the bucket. The burst capacity is how many tokens I can use at once. So that means that I can send 20 requests at the same time, then the token is empty, and I have to wait for the replenish rate for having 10 more tokens. And then the requested tokens, how many tokens are necessary to send a request. So how much it costs to send a request. In this case, 1. So we have 1 token per request. At most 20 requests, that's the burst capacity of the token. And every second, we get 10 more tokens. Let's rerun the application and see how that works. Yes. So if you are wondering what are these errors, this is because I'm using an Apple computer with the M1 processor, and there are some incompatibilities that, the application still works, but there are some errors there. Yes, so the application is running. So what happens now is that if I send the request to 9000/books, Of course, I get the response back, but now I get also some extra headers. So this says, basically informs me about how the request rate limiter is configured and how many remaining requests I got. This is the default behavior. Of course, this might be dangerous because if there is a bad actor that is trying to put our system down, we don't want to provide this information, probably. So you can disable it via a configuration property. But by default, it's there. So now let's switch to one of my favorite patterns in the resilience ecosystem, the circuit breaker. We have talked about retries. Retries help with get request. We have talked about request rate limiter, but that's at the ingress part of the system, at the entry point. But what happens if book service becomes momentarily unavailable, or more or less momentarily? Do we want edge service to keep sending requests to book service with the risk of propagating the failure? And this question is also true for any kind of interaction of integration point between two systems. Every time you have two systems, you should consider what happens if one of the two items fail. Will the failure be propagated to the other one? We want to shield the rest of the system from any kind of failure. We want to block any kind of error within a single service and have all the others then deal with perhaps graceful degradation of functionality. But it's really important that we don't propagate that error. And circuit breakers are exactly for that. Of course, this comes from the electrical world. When a service downstream, let's say book service is down, we just open the circuit. So we block edge service from sending requests to book service, at least for a while. And then we try again and see if book service is up. We have three states. At the beginning, the circuit is closed. All is fine. Every time a request arrives to edge service, then it's forwarded to book service. But if the failure rate goes above a certain threshold, so let's say that in 100 requests, at least 50% of them return an error, then we can trip the circuit, it becomes open, and no request is allowed to pass. So at that point, basically, we have the edge service, in this case, not sending the request to book service, but returning directly something to the user. And again, it could be a friendly message saying, please try again later, we have some problem, or it could be a cached value from a previous request, or some nicer way of ensuring a nice user experience. After a while, we want to check, so we want to explore the situation. So let's see if book service is up and running again. So we move to a half-open state. In this state, we just allow a few requests to go to book service, just to see if one of them at least is successful. And then we do the same, we apply the same logic. If the failure rate goes above a threshold, then we move back to open. It means that there's still problems with book service. Otherwise, everything is good. We go back to closed. Now, just by looking at this diagram, it might not be entirely clear. So let's have a more graphical look at what is happening behind the scenes here. So first of all, I'll switch branch, circuit breaker. Spring Cloud Gateway offers a filter for circuit breakers, but we need to add the implementation. So we have the circuit breaker project, Spring Cloud Circuit Breaker, and it's basically providing auto-configuration for Resilience4j. Resilience4j is an awesome library providing the implementation for several resilience patterns. You can use it in any Java applications. And in the Spring world, we have the Spring Cloud Circuit Breaker that provides some auto-configuration, and it provides some better integration with the rest of the Spring Cloud ecosystem. So we're going to use this dependency in our system now. And this one, we are using it in Spring Cloud Gateway, but you can use it in any Spring application. Actually, it's recommended to have circuit breakers between any two systems that interact with each other. As I said, the integration points are really important when we analyze the resilience of our system. So we might want to consider adding circuit breakers also in the backend, not only from the edge service to the backend services. All right, so I'll rerun edge service now. And I have a Grafana instance. Let's log in. The Resilience4j project provides a dashboard. It's on their website for monitoring circuit breaker. So from here, we can see that, let me select the application. Oh, yeah, so host internal, yeah, this is Dogger, 9,000 per 9,000, that's edge service. We can see that there is one closed circuit breaker. So now the circuit breaker is called book service. And what is a book service is a filter that we have configured in the application. So if I go back to our good old application property file, we can see that we have a new filter, circuit breaker, with the name for the circuit breaker. And optionally, we can also define a fallback URI. So if the circuit is open, we can redirect the request to an endpoint implemented within the gateway. Now, in here, for this example, I'm just returning a void object. There it is. It's a standard REST controller with a get mapping /books fallback. But it's here that then you can perhaps return a cached value or something else that might be useful to the users rather than having just an empty response. And then we have the dashboard here, so let's give it a try. I'm going to use a tool, it's called Apache Benchmark, to send several requests at the same time. So I can say AB, Apache Benchmark, and then I want to send 10 requests concurrently to localhost 9,000 /books. Now, why 10 requests? 10 requests because I configured the Resilience4j circuit breaker to consider a time window of 10 requests. So over the 10 requests, then the implementation of the circuit breaker evaluates whether the circuit should be open or closed. And that's in the application properties file. This comes from Resilience4j, so we can see that we have configured the book service circuit breaker instance. We have a sliding window of 10. It means that we always evaluate the last 10 requests. The failure rate threshold is 50. So if more than 50% of the 10 requests fail, then the circuit trips. We have also a wait duration in open state. It means that we're going to wait 10 seconds before exploring the situation and see if we can close the circuit again. That is the half open state, where we allow only 5 requests. And if more than 50% are successful, then the circuit becomes closed again, and everything is good. I have also configured the time limiter. This is also offered by Resilience4j, because I want to give the system a bit of time before declaring a request failed. That's 3 seconds. Might be too much, but just for demonstration purposes. So at this point, we have one closed circuit breaker there. I send 10 requests. And I expect the circuit to still be closed because book service is replying correctly to all the requests. But what if I shut down book service now? Let's do that. So now book service is down. What happens if I send 10 requests? I expect the circuit breaker to trip and become open. There's a few seconds lag because of Prometheus scraping. So drum rolls, let's see what happens there. Maybe I can even refresh. Yes, now the circuit breaker is open. And this is extremely useful. So if you use circuit breaker, first consider monitoring around circuit breakers, because you really want to have an overview and set up some alarms so that every time a circuit breaker becomes open, you get an alarm and you can act on it, because it means that something bad is happening in the system. So in this state, it will remain for 10 seconds. After 10 seconds, it switched to half open and allows 5 requests. So I'm gonna send only 4 of them, and let's see what happens. And now the circuit is half open. So we sent 4 requests. They were all failing because book service is still not running. So if I send one last request, I expect it to turn, let's go with 2. So we are going more than the 5 from before. It goes to an open state. And while it figures out the scraping, yes, so it's open. Let's see if I start book service again, what happens then. So book service is running. Yeah, in this dashboard provided by Resilience4j, you have a lot of different informations, not only about circuit breakers, but also about all the other resilience patterns that are implemented there. But we can say that, yeah, for now, we have a lot of failures. Of course, book service is down. So let's try to make it healthy. So I send 4 requests once again. So the circuit become half open after that. But book service is running here. So you can see there's a log message for each request, returning list of books in the catalog. So they are all successful. And there it is. The circuit is half open. Let's send one more request. And we expect the circuit to be closed again. And the system becomes healthy again. Yes, the circuit is closed. All is good. And since I'm here, I also want to show you something else. Spring Cloud Gateway provides some metrics by itself, some additional metrics that you can use to identify, for example, successful and unsuccessful APIs or the throughput. We have some data about JVM. All of this is in a GitHub repository, so you can download the code and try it both on Docker and locally and Kubernetes. Yes? Moving on. That was the circuit breaker. We also used a time limiter with that. So we had a time limiter for each request in order to know if we had to use the fallback in the circuit breaker, or maybe if it was successful within the time limit, then everything is good. Let's move to user authentication. So we have talked a bit about observability. We have a system, at least the entry point is a bit more resilient. So we adopted retries, circuit breakers, request rate limiters. We want to have the edge service also scaled out because we need to ensure high availability. But we haven't discussed security. Since this is the entry point to the system, we can use it to authenticate the user. And we can do that directly into edge service. Spring provides the Spring security library, so you can build your own security logic within edge service itself. Or you can use an external and dedicated authorization server, like the new Spring authorization server project. But the problem we are trying to solve here is at that part here, edge service, we want to delegate the authentication to an external service, whatever that is, but we need to consider which strategy to use, hopefully a standard strategy, which protocol to use in order to delegate authentication to this external service, and then the data format to exchange the information about the login event. So the user authenticates successfully. How can I let edge service know about that? And the one of the options for doing this, quite used in distributed systems, is OAuth2 and OIDC. OAuth2 is an authorization protocol. It doesn't deal with authentication. That's where OIDC, OpenID Connect, comes handy because it adds an authentication layer on top of OAuth 2. So the user will access the system via edge service, but then the authentication will be handled, for example, by Keycloak, by an external service. And that's the first step, because once I have authenticated and authorized the user with edge service, I have a distributed system. So how can I let know all the other services in my system that a certain request belongs to a specific user? So how can I propagate there the security context? And how can I have edge service be granted authorized access to book service on behalf of the user? These are the two questions we need to answer. And again, we can use OAuth 2. In the case of web applications, what I like to have is keep the good old session cookie between browser and edge service. Edge service will keep a mapping between a session cookie and an access token that is returned by, for example, Keycloak. So we're talking about OAuth 2. And then that token is forwarded to book service and the other services in the backend that in OAuth 2 are called resource servers. Yes? So at this point, you might have guessed that we can use a filter once again to achieve this. So I'll switch branch. In order for implementing this, we need extra dependencies on Spring Security. So in Edge Service, we're going to add the OAuth 2 client dependency. Edge Service is the client means the component that delegates the authentication and authorization to the auth service like Keycloak. Instead, book service and all the other application in the backend will have the OAuth 2 resource server dependency. Spring Security, there it is. So Spring Security by default protects all the endpoints. So it employs a strategy of security by default, which is really great. So after adding the dependency in the project, all is left to do is configuring the integration with Keycloak, which I'm using for this specific example. So in the case of book service, I need to point to the Keycloak server like this. So I'm using the same trick as with book service. If I'm in the local environment, I'm using localhost 8080, pointing to a Keycloak realm where I have defined all my security policies. Otherwise, I get the value from the Keycloak URL environment variable, if it's defined. That's all I need to do in book service. In edge service, I need something more, because in edge service, we also need to delegate authentication to Keycloak. So what we do there is not only point to the Keycloak server down here, but we also need to authenticate with Keycloak. So we're using a very secret, yes, polar Keycloak secret there. So this application is registered in Keycloak. It means that it's authorized to use Keycloak for authenticating users. And we want to use OpenID in order to authenticate the users on top of OAuth 2. Once again, this is all we need to do to integrate with an external OAuth 2 provider like Keycloak. But since we are in Edge service, we also need to take care of a few more things. First, since we are using Redis already, I want to externalize the session data and store that in Redis. So I have no problems with scalability. All the web session data will go in Redis. Then I use two default filters. One, to save the session before forwarding requests downstream. And the other one is to include the token in a request. So I don't have to do that manually. But the token is added to each request automatically for me. After doing that, I'll start the application again. I have a Keycloak instance running locally. Let's give it a try. Book service is running. Edge service should be running too. So we have 9000/books. Since Spring Security provides security by default, this endpoint is automatically protected. And do I have Keycloak running? Keycloak is running. How about the application? I know why. I switched branch. Yes. Book service. Add service. And it started. Now I'm redirected automatically to this page. This is provided by Keycloak. I can authenticate with username and password, but at this point, I can implement whatever strategy I want. So for example, I could authenticate with Twitter, with GitHub, with Google, and Edge service would not know. So Edge service is shielded from the specific authentication strategy that we implement in Keycloak. And that's it. Now that we are authenticated, we got the response back. Book service also was protected. It checked the token that received automatically from Edge service and returned the response. And that was it. Thank you very much for joining. I wish you a great conference and have a great day. Thank you.